Yeah, welcome everyone. Let's roll this out of the door here. Officially the last slot. I just arrived this morning pretty late, but from what I could see on Twitter, it's been a pretty great conference, and I'm happy to be able to be back. You'll be enjoying the quickest rundown of this talk ever. It originally started as a 3-hour workshop for another conference, and then got basically shrink down to a 1-hour one, and now we have 50 minutes. So let's not waste any time. My name is Oliver Gierke. I work for a company called Pivotal. Has anyone ever heard of Pivotal? Oh, that's getting more and more arms over the years. Like it seems to be an unpronounceable company name for the average German, really. Pivotal is the company behind the Spring Framework, so most of the engineers on Spring Framework are actually employed by Pivotal. We have this other thing called Cloud Foundry, a cloud platform, which you can use to run your applications of whatever language in the cloud on whatever cloud provider you want to actually use. And I'm in particular responsible for the data project. So everything that's not inside the core Spring Framework and is sort of starting with Spring Data, yada yada, is sort of maintained by my team. I ran across this tweet recently by that lady named Cathy McCaffrey, and I thought it's a pretty good summary of what I want to do with this talk, and especially with this kind of audience here at this conference. I guess I might choose different focus points on, like, of course, delivering the same content, but focusing on certain aspects of the stuff I'm going to present. And one of that is going to be that ideally, in theory, we basically do some kind of architecture to plan our system or our system of systems, and then we choose technology, right, to actually implement these individual systems. But oftentimes, and very unconsciously, that technologies we choose is having an effect on the way we actually build software, and that will become a focus point of a lot of the steps we're going to take. So let's dive right in. I'm going to start with a monolithic application, in this case built using the Spring Framework. It's a bit a stereotypical project, so it's by far not something I'd recommend to build that way in the first place. It's also not something I'd not recommend to build that way. It's just a reflection of a lot of stuff that I've seen through consulting gigs and whatnot. And I want to focus on the interaction patterns between bounded contexts. I'm not going to go into DDD and all these aspects into like much detail, but it's basically like business modules that sort of interact with each other that you usually have in your monolithic system, whether you want it or not. It's a bit like architecture, you can't have none, right? But what are the interaction patterns? And sometimes I guess we're going to digress into the way that, let's say, some technology actually makes certain things or creates incentives to do certain things in a certain way. We're going to then look into basically the effect that most conferences these days have, right? Developers attend these conferences, go back to their offices, and then learn they've got to do microservices, which means bounded or system per bounded context. So they go ahead and split these modules apart, turn them into individual deployable units, hopefully, and then have to replace these interaction patterns with now remote interaction patterns, right? And what the effects of that are, and whether these effects are not sometimes even hindering us in terms of the actual goals we wanted to achieve with that separation in the first place. So that's basically the question I want to answer, or basically cast some light on to the problems that create if you're just like blindly following those ideas. And then we want to take a step back and actually have a look at how can we maybe improve the monolith in the first place, make it more modular, and what actually putting some meat behind that more modular phrase. So maybe we can build a better monolith and can just like call it a day with that, right? So maybe that's enough for us, or to achieve the goals that we actually plan to achieve by separating the system. And finally, like the last couple of minutes, I want to spend on, okay, we have this, let's say, improved monolith, and we now still want, for whatever reason, split up the system into multiple ones. Then these systems probably want to or have to talk to each other, and there's like usually two ways to actually achieve that, and one is by using messaging and one is by using REST, and I'm pretty sure that like most people at this point of the talk imagine something completely different when they read communication via REST than what's going to be shown in that case. So a bit of housekeeping. For these individual stages, for these 5 actually, there's sample code. So basically, as I said, stereotypical implementations. These sample projects are not like done in terms of like completely polished or whatnot. I actually just like implement them to showcase the interaction patterns, what have you. So we have the microlith implementation, the monolith first, the microlith, the modulith, and then 2 for REST and messaging. The slides are already available on SpeakerDeck if you just like look for them. They are not the slides, the exact slides you see here today, because I created a commented version because a lot of the stuff doesn't really make sense without some explanation to actually read on the internet. So there's basically a commented deck. And there's also a couple recordings already. So in case you'd like to rather follow this stuff along in German or over 2.5 hours, YouTube is yours, right? So anyway, so what's the domain I'm going to talk about? And that's actually a good point to actually, or to let me do this first and then come back to the point. Sorry. So we're building an e-commerce system, sort of consisting of a catalog that has products and prices and product details and whatnot. Those products can be ordered, of course, right? So you have the order and the line items, and you have some kind of inventory to keep track of the stock of the individual products, right? And that's a good point here to actually make clear that all the recommendations or the observations that we sort of get to or going to get to might be completely different if you build a different kind of system. So in case you're building a stock trading, real-time stock trading application for Deutsche Börse or what have you, some of the conclusions that I come to will not actually apply. So that's like sort of the context that I set around. I'm not only setting the context with the domain, but with the kind of system that I sort of imagine in this case, right? So some kind of server system that has clients, whether mobile or a website, to interact with these systems. There are 2 scenarios that I'd like to actually look at on a like case-by-case basis, so we're not always looking at the 2, but pick them out individually. One is that when we add a new product, we want that the inventory is basically performing some initialization activity by initializing its stock to 0, right? So let's say we start to sell books or a book of a certain kind, then the inventory should basically register, okay, we have 0 of this particular book in its stock. And the other use case is that when we commit an order or complete an order, then that inventory has to be updated for all the line items in that order. So if I order, like, let's say 25 televisions, then that particular television, they have to be cut down. And like these 2 samples are, especially the latter one here is one that raises all kinds of interesting questions in terms of like consistency of transactionality of how to actually, how the system should be talking to each other. And we're going to look into those. So the monolithic implementation. So within the monolithic implementation, what does it usually look like? As I told you, or the systems I usually see, and that's probably a self-fulfilling prophecy, is Spring Boot on Java-based systems, Spring Boot or Spring Framework-based systems. I'm assuming like JPA here, so relational data access, so pretty, as you can see, like pretty conservative. Some people would say boring, what others say, but that's just what it is outside in the real world, right? So the catalog has some kind of, it has an entity or an aggregate, like with product. There's a different sets of like product detail information, and the order consists of, it's a slightly more complex aggregate as an order with line items, and the line item in this case is referring to the product by a class reference, right? So I'm not going to show you this in code here, but imagine you have that line item class and it has a property called product, and it's by that pointing to that product, right? And this approach usually stems from the fact that people either use like reverse engineering tools from databases, or to look at databases and create their entities and not really think about, okay, think about bounded contexts and aggregate boundaries in the first place, right? And if that's missing, you get to actually exactly that. So what problem is this causing? Yeah, you basically, like, let's say you have an order, I've placed my order, and 2 weeks later someone is changing the product description, then within that order the description changes. It's not really changing, but because it's just you're referring to that product, and it's like it stays consistent basically. And in this case, it's something we don't want, right? Because the description in the line item is actually semantically it's something different than the description of the product at a given point in time. So that's stuff that, like in this case, again, technology sometimes makes easy to do because it's just so you can just like many to one product, what have you, be done with it in that class. But at the same time, it basically allows you to just fall into that trap very easily. Same thing with inventory, whereas in this case it usually doesn't really matter because the inventory item is basically a product associated with the number of items already or still available. So there's no data inconsistency question here in relation to the product, at least. And what we usually see is that that there's a direct invocation of, or when you have that, let's say, piece of code that says, okay, inventory, go ahead and update that your stock for each of the line items in there, right? So what we usually see is that, already assuming things being done sort of or slightly correctly already, if correct is an option here or is something you can really speak about, but and you will see that in the sample code if you have a look at that. The system or that monolith here already like uses packages per bounded context, which is a nice way of separating things, because then you can already use package scope. That's very Java specific, of course, to actually hide things from each other. One thing that's often undervalued is that invocation, that communication between the bounded context, is a process local invocation. So there's no serialization going on, there's no network communication going on. So it basically, there's just two options: either the method call returns and yields a result, or throws an exception in the case of Java, right? So the other thing is, like, compared to something like messaging, we basically got exactly once delivery for free, right? And this is something like you really have to or that gets a lot more complicated because there just is no exactly once delivery in all these remote invocation scenarios here, especially messaging. So, as I said, or what I'm assuming here is that the domain classes are being used as reference points even across bounded contexts, just because of the fact that, the package names aside, it's not entirely obvious like where the bounded context boundaries or where the aggregate boundaries are, unless you actually take the time and sort of create yourself means to express that in your code base, right? So additional annotations or what have you. I qualify this as pro and con, because on the pro side, that really, or doing that really makes your code refactorable, like changeable, and it's something that's slightly counterintuitive if you think about it. You have like tightly coupled code, like in your monolith, right? Because you refer to that other type, but at the same time, it's highly changeable because you can just like use your IDE to, let's say, rename a class, rename a method, what have you, because you can change, or because you change caller and callee at the same time, right? So it's like it's giving you that flexibility, but as I said, there's also this downside of, in this case, the semantic inconsistency that you could create actually after the fact of the order. The invocation of the order, or of the inventory from the order management, I guess I should just show you the that other. Yeah, geez, you should have prepared that. Where is it? I should show you. Nope. Monolith. There it is. Jesus, let me show you the method order manager. There was a broken test case. Who came up with that? anyway, so the thing I'm talking about and the interesting bit actually is this here. So you have this kind of like order manager class that's just like a component, if you're not from the Java space, that's managed by the Spring Framework in this case. It has an add transactional on it, which means that particular piece of code is running inside a transaction, so it's executed in all or nothing fashion. So, and basically that code is called to complete the order, as the name suggests. So we change something in the state of the aggregate, and then we have that other bounded context code that's sort of invoked directly, and then we persist the change of state in the order. And this has a couple of like up and downsides. I mean, it's like literally it reads pretty like as a step-by-step fashion, but it has a couple of effects that are not immediately obvious here, right? So the first thing is there's a cyclic dependency between the two like pieces of code, right? The inventory needs to know about the order, and the order needs to know about the inventory. So we sort of couple these two bounded contexts already. And the other thing being that it's that add transactional that you have here is like a decent way or a nice way to actually create that strong consistency between the bounded context or across the bounded context, because it's just so very convenient to just drop the annotation there and then basically just get it for free, quote unquote. Right? But that actually means that like if you like want to associate more functionality, more business functionality with that point in time, the order completion, then that also actually becomes part of the very same transaction, which means it's kind of like expanding the transaction, right? It's associating like secondary functionality with the main use case, right? Let's assume some kind of rewards program that we want to introduce and basically allow customers to collect like credit points or whatnot per order. We could like even have a team. It's completely developing that algorithm, that functionality in a separate package because it's a new bounded context, fine. But we wouldn't get around the fact that we have to go and change this piece of code, that particular method, to then put the dependency on the rewards component in there and then invoke the method, right? And then you could ask the question, let's say there's a bug in that new component, and if that's rolling back my transaction, the entire order completion, is that something I really want? Right? So it's like complicating the picture. It makes testing harder, what have you. Right? So let's get back to this one. We had those already. Yeah, and that's sort of coming. It's the last couple of points actually. So we actively invoke the other bounded context, the functionality in the inventory bounded context, and by that we sort of like intermingle two things. One is there is the step of updating the inventory in the first place, and the other thing is actually knowing when to do that. And that knowledge is basically has to be baked into the order component, which is sort of like distributing the knowledge about that stuff across two different bounded contexts, which is like probably not a good idea if the initial idea was to separate things from each other. Easy to refactor, I already said that, because we can use our IDE to just freaking move code around from A to B. We can rename stuff. We can introduce new methods. That's pretty easy. We get some kind of like changeability here. We have strong consistency, and that's like a convenient thing in the first place. Whether that's a good thing, I already discussed that. Hence that thing. And also, like a slightly different way of phrasing it, the order management becoming a central hub of new features is sort of an effect of the lack of explicitness, and that's something that domain-driven design talks a lot about, right? So besides that name, complete order, that method name, there's no real embodiment of the actual business event, the order completion, right? And that's kind of like it becomes obvious in that particular method. And if you see like code from the real world, then you have these classes with 15 different dependencies, and then those important methods in the code base where like these 15 dependencies are like called one after another. All right. So let's assume like we have a team that was used to build systems like that, right? And they attend these kinds of conferences, and then are getting back to the office, like let's say on Monday morning, and then they get told bounded contexts have to become separate systems, right? So they go ahead and basically take the package, take the order pack or the catalog package in the first place, and turn that into a separate Spring Boot project, and then go ahead, put an API on top of that, probably, because these things have to interact with each other. The order system has now, like, sort of to refer to the product in the first place. So that's actually a new challenge, right? Whereas before we could just like have the product class embedded in the line item, how do we actually refer to the catalog now? And how do we actually resolve that information? So that's, I mean, we're using REST, I'm assuming, right? So it's kind of like there's some nicely designed URI, and then we can actually point to that thing, but then we have to issue a call to actually resolve the information. So things get slightly more complicated. That's what I'm kind of saying. And we're actually leaving the system boundary. That's the thing here. Same goes for the inventory. The catalog has to notify, actually there's an arrow missing here. The catalog has to notify the inventory like about a new product that's being added, but at the same time the inventory has to sort of refer back to a product, right? So because of the fact we need to, or we want to store amounts or the stock for an individual product. And just as the order sort of then has to notify the inventory. So if we go ahead and basically replace those communication structures between the bounded contexts, we usually end up, in this case with the inventory update, with an HTTP post request, right? Or let's say it could be a put request under certain circumstances, but post is usually like the last resort kind of thing, and it's also the most inconvenient HTTP method to use. Why is that? Can someone, anyone? Why is post? Go ahead.
It's not in the pod.
The answer was it's not idempotent, and actually that's part of the problem here. See, we've just replaced a local Java or JVM method invocation with a call invoking serialization, a network request, deserialization on the other side, and then the response going back the same way, right? And if we don't receive an answer at that point, like on the caller side, what do? Like, we don't know whether the request never arrived at the call system, or whether the response was just lost on its way back, right? So it's kind of like getting more complicated. The same goes for the initialized docs scenario. We'd have to issue some new or some HTTP request in that case. So a bit in more detail. The first thing we lose is our nice local transactionality, right? And that's usually the question I get. Oh, we build microservices now. How do we actually like get transactions to span these services? And the answer is you don't, right? So, what's the key here? Basically, accept that you can't have transactionality across those. I mean, you can technically, but that sort of like subverts the entire idea in the first place, because like with two-phase commit, you couple these systems again, and then it's like not really non-performing. So I'd abandon the idea and basically get used to eventual consistency, which sort of means accept that you have like strong consistency within one system and eventual consistency across system boundaries. That can actually be used to the first point still, that can actually, or is often a trigger for some more interesting like business discussions where people go ahead and start like, okay, if we can't actually assume strong consistency, what do we actually do in the case of, let's say, with that when we order like the TVs as I told before, let's say we have like 5 TVs left in stock, and now I'm ordering 3 and someone of you is also ordering 3. So like if we do it at the same time, then like if you think in strong consistency terms, one of us is not going to be able to actually order the TVs, right? But at the same time, you could go ahead and say, okay, if I don't really know I don't really for sure know the actual stock of TVs in the first place, why don't I just accept the order, and in case I basically overdraw my stock, I just like go ahead and order new ones myself. Right? So it's kind of like, and this kind of view on the world, so making that problematic use case, the use case that required strong consistency so that we could keep our system in consistent state, could just be used to actually, or as a trigger for some business decision, and then basically advanced, business processes really. Interaction patterns. Okay, sorry. So the point I'm trying to make here in this bullet point is the fact that that oftentimes the answer to technical challenges that developers introduce is more technology, right? So if we went from JVM local call to a call that requires serialization, deserialization, HTTP communication, which means if the other system is not there, we need to have fallbacks, we need to have a circuit breaker pattern implemented, what have you. And then all these kinds of technologies emerge around these challenges, which is great. And all the stuff I listed there is great technology. It's just that, like, with that stuff being available, I see a lot of people just blindly going for, okay, we can just like call left and right other systems because we have that technology at hand, and then basically like build our entire architecture on top of that concept. The thing is, oftentimes you're better off just trying to not create the problem in the first place. What if you could just avoid that call to the other system, right? I mean, it's not that you, I mean, if you have different separated systems, if they don't talk to each other, they're probably not going to, in combination, deliver any business value at all. So there will be some communication. The question is when and how that actually is supposed to happen. But basically, just like at the point in the code where we previously had inventory update stock, just replace that with REST template, yada, 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 and then having an add fallback annotation or something on the method might be like a convenient, quick solution, but it's usually like causing more problems in the long run. Yeah. So the fundamental problem I see here is that when the system ever gets a single system of that entire like system of systems is getting into a scenario where it has to call another system while it's actually serving a user request itself, that's where problems like gather up, I feel. Right? So it's kind of like, if we can avoid that, if we can just avoid calling other systems while we try to be useful ourselves, then that makes a lot of things easier, and I go into detail what that actually means. One of the reasons that's problematic, so reaching out to other systems while you're serving a user request yourself, is the first thing is you need to know where the other system lives. Admittedly, you don't actually get around that entirely, even if you can basically delay that call or basically find a different way to actually call the other system. But it also, that sort of like sneaks into like very fundamental activities around your system. It basically causes that you can only test the system while something else, like at least a stub or a mock server is available, right? If that call wasn't necessary, then I could just like invoke my business functionality and sort of like set up some mock database state or what have you, but don't have to mock an entire different system, an entire API that I sort of have to adapt whenever that API changes, what have you, right? So try to avoid that so that you can actually change it more easily. That's a bit of a sidetrack. I don't want to spend too much time on. What I mean here is that as we usually move to very RPC-ish kind of interaction, I often see that interaction pattern to sneak into the way we define our APIs. And that comes from a very strange idea, I think, which a lot of people don't seem to think is strange. But if you remember, we had that inventory and we had that order management, right? It's basically a class invoking a method on another class. Right? And that's just defined by, in this case, Java JVM language means. And that causes tight coupling, doesn't it? There's the name that has to match, there's the types that have to match, and what have you. And in the monolithic case, you'll always be in a situation where if you'd want to change something about that, you change both the provider of the API and the client of the API at the same time because you're using your refactoring tools. You can't just change the method and not change every callee. So by definition, that way of defining interfaces and defining interaction creates very strong coupling. Would you agree with that? Anyone not agreeing with that? So, okay, let's say we agree on that. When we started to separate the systems, we wanted loose coupling, right? Because we want to evolve them at different paces. And why in the world are we thinking that if we use the same means of defining an API, are we coming to an API that allows loose coupling? That's kind of weird, right? So all these kind of, I see a lot of, did I mention that, have a bit of a weird relationship to the consumer-driven contracts kind of idea, because there's so many assumptions in there that I don't think are actually valid if you create a microservices system, right? It assumes you know the consumers. Well, I'd argue you most oftentimes don't, and it's better if you don't even assume that you actually do. But again, if you want to see me get into detail on that, I'm recommending let's say one of the 2.5 hour recordings here. Right, so that's basically what I usually see happening in that kind of, we try to do REST, but we actually end up with RPC in this case. So if we want to go back, so let's say we are not satisfied with what we got, and we can actually look into how to improve the monolith in the first place, we could slightly change our mind and think about or come to this concept called events, just without any technical association yet. We could decide we want these individual bounded contexts to create events and to propagate events. That might be coming from a totally DDD-driven kind of approach to things, because we just, as I said before, we want to make that event of the order completion explicit, right? And we want to find some means to actually do that, but we'd actually go ahead and we can still keep our product reference in our order. We'd probably rather copy the description, as I said before, because otherwise we're just creating issues in terms of data consistency. But again, we would go ahead and raise an order completed event so that then the inventory could go ahead and subscribe to these events and get the events published into itself, right? So it's kind of we're basically inverting the control structure here, right? So it's not the order management actively invoking the inventory. It doesn't actually even know what kind of secondary functionality has to be applied when the inventory or when we complete an order. It just signals an order has been completed. I think there's been a couple of talks that sort of went into that general concept, right? That would even then allow us to go ahead and in case of that overdraw of stock that I just mentioned, we could signal that through an event ourselves, and then some hypothetical other system basically consuming that, right? So, oh yeah, let me just show you what that kind of looks like. And again, I don't want to spend too much time on the implementation, the Spring specifics in this case. Let's have the inventory listener. That's an annotation-based model. You just have a method in this case where you go ahead and say add event listener, and product edit is just a plain value object in this case, right? It's just a class that represents the event, and that event in this case on the producing side, there's some Spring data magic that we just have to actually have change or can change our implementation code to actually look like this. So that call to order complete is sort of producing the event. It's published when you call save here, and then it's being propagated into the listener. And it's based on a Spring Framework feature called application events. If you're like into the plain Java EE stuff, if you want to be more conservative, then there's like CDI events that allow you to do the same thing. The nice thing, or the reason I show you that that stuff here is that we actually get into a model where we can work with events. We can actually use them as a first-class concept in our domain code, but we don't change a thing about the ways we actually deal with consistency, right? These events would still be submitted synchronously. They would still take part in the transaction. You can, of course, also asynchronously handle those events, but by default, the default mode of interaction just sort of stays the same in terms of consistency. That's kind of nice, right? Yeah, that's sort of not that obvious from the code I've just shown, but the aggregate is in this case getting the responsibility to actually create these events, and that's kind of like in line with what DDD teaches you anyway, which is that the aggregate is sort of the place where consistency happens, and consistency is basically like shaped around aggregate borders, and that's why they also like create the events about things that have changed. We basically flipped from method invocations to event publication. That's fine. And we could basically invoke or invert the invocation order direction from order management to we basically make the framework, or the platform in this case, responsible for publishing the events. All right. That approach in general actually gives you a nice segue into the separation of a system into individual ones in the first place, because like oftentimes I see talks where or I have seen talks where people like go, okay, there's microservices, and then you of course want to do DDD around those, and then advanced DDD means CQRS and event sourcing, and then like literally everything you just like done the last 10 years or 20 years, it's just like obsolete, right? So no relational persistence anymore, like everything is just like completely upside down. And that's actually not the case, I think. So you can actually move with the stuff you have into that direction. You can just go ahead and start using those events, publishing these events, without maybe someone in the first iterations, not even someone actually consuming them, but just logging them and seeing, okay, what kind of happens in the system, right? Can remove log statements from your actual application code because it's just all in the event handling. And then it allows you to like be very selective about, okay, there's a particular event that might be interesting to some other party, right? So even within that monolith, you could go ahead and take the event, listen to the event, and then talk to whatever messaging infrastructure you have, be it Kafka, JMS, what have you, and publish it, externalize the event selectively, and then basically take it from there, gradually like learn and grow with into this kind of style of interaction, right? So, that said, assume we now, let's say we decide we want to extract our inventory bounded context into a separate system for whatever orthogonal reasons, be it scaling or what have you, right? So we want to externalize that. Then these two, or the systems have to talk to each other, and the way that usually happens is either by using messaging or REST. And I want to focus on especially these two approaches being implementation versions of implementing events, actually, and like implementing events via REST might be something that, or oftentimes is something that people don't really have on their radar because they always assume this kind of like synchronously calling out to another system being what's meant when they say interacting via REST, right? There's a couple of other questions that I want to like cast some light on when discussing this. First one is, what do I need to actually run a single system? Second thing is, what happens if a system, one of the systems goes down? Like, is anyone else affected? And if so, how? What happens if the failing system, or a system that failed, comes up again? So what kind of state does it see? What kind of, how much does it actually get notified of the stuff that happened in between? And as a sister variant of that, what happens if I want to just like put a new system into that system of systems, and what kind of options do I have to actually see stuff that already happened? Let's have a look at the messaging variant first. So the fundamental idea is that you put some kind of broker in between, some kind of messaging system. In this case, Kafka seems to be a fashionable thing these days. It's also often used for because of a different aspect compared to things like JMS or Rabbit. I'll go into that in a second. And then the idea basically is that you have these individual systems that externalize their events into that broker, and by that, sort of like on a timely decouple the sending system from the receiver system, right? So in this case, the inventory system doesn't actually have to be alive at the point in time when we actually say we have added the product. Kafka will, or the broker will actually make sure that it's then delivered when the other system, the receiving system, actually returns or comes up under certain conditions. But I get to that in a second. Product added could be like also forwarded to the order system, because like assume you actually implement that duplication of data or redundant, keeping that product information redundantly, so that the orders can actually capture the state of the description at the point in time when the actual orders happened. So that picture basically just completes. Yeah, you have these events flying around, and the thing that struck me quite a bit was that, isn't it a bit weird that we just learned that microservices actually means that we want to build individual systems, right? They're supposed to be self-contained. They're supposed to share nothing, share as little infrastructure as possible, and then we put this thing in the middle there, and then that everyone uses, right? I've been to these meetings where literally there were different teams basically arguing that they want to use that Kafka message broker, but who's responsible for that thing, right? So who's responsible? I mean, you basically define how long do the events actually live in that Kafka. And even if the order system, I mean, there's of course this API where, let's say, a producer of events can then, like on the creation of the topic, can define the lifetime of the events, but it's actually living in some other place that you don't really control yourself, or that you're not owning yourself, right? There's nothing wrong per se about it, and there's like, of course, different things. Kafka makes it particularly easy to have like a clustered instance in different regions, or Amazon regions, for example. But it's kind of logically, it feels like it's a bit like contradicting the idea, right? So that's kind of the thing. So we have shared infrastructure, which might be something you're like put off by or not. Yeah, the broker keeps all the messages around. That's like a particular trait of Kafka in this case, and we sort of consider these events, or we implement events by as messages basically, right? So that's the key thing here. What you have to be aware of, that, I mean, the reason that Kafka is used is that it's sort of like slightly different, or used often these days, is that it works like with a slightly different default than the other technologies I've listed, JMS and Rabbit, or MQP in particular. It basically keeps the messages around, whereas in the other scenarios, you usually like keep the messages as long as someone has either signaled that he or she or it is actually interested in it, which makes the difference that you only get messages pushed into your system once you've just like initially registered with the broker, right? So with durable subscriptions or whatnot in JMS, or what is it, fan-out exchanges in AMQP. So you're not able to actually see old messages unless you've initially subscribed to the broker. Which the use case that we usually had, or we had back in the day, was that particular reward system for the orders. It was actually there was a company that took a system, that reward system, live, and at the point in time where they took it live, they were able to already like stream or process all the orders of the last couple of years just by like resubscribing to that orders queue or orders topic, and just like running all messages through it. That was kind of like decent. A lot of misunderstandings I see are like in terms of is coupling any different than from the REST use case? Yeah, or let me phrase it around. I hear people often arguing we have our system decoupled because we're using messaging, which is kind of like meaning nothing really, because all the coupling is in the message serialization format, and there's I'm not saying no way, but it's not like a first-class citizen. Things like content negotiation is not a first-class citizen, so you can't easily introduce at a later point in time a new format for the messages. I mean, you can by just like listening to the messages and then republishing them in a different format. Fine, of course, but it's not like the messaging doesn't have that as first-class concept really, which might become problematic when it comes about like changing the structure of messages, because then you have to do a lot of things yourself. Transactional semantics, something that a lot of people also oversee. If you have a relational or transactional data store and want to publish messages at the same time, then you literally have to like run two-phase commit for your local service in the first place, right? Because assume you just like, you want to write to your database and then you want to send out the message, and then the commit fails afterwards, then you've sent out the message already, right? And then you can, I mean, the other option would be to send out another message saying, okay, oops, that order that I've just completed wasn't really completed at all, but that just like complicates things, and I usually see people like working around this with 2PC in a local fashion, not spanning multiple services, but just for the local service. To round things off, how could you actually even implement events in a REST way? And it turns out it's not even that not a fancy thing actually to do, because we could just go ahead and assume that events are part of the local application state, right? Which makes a lot of things very easy, because considering them application state means that we can just like literally write another entry into our database when we've just like used a local transaction anyway. And so instead of just like entering in the case I just mentioned, adding a new product entry into the database, we also add an entry for a product edit as event, and then provide some API where we can actually expose that and allow clients to actually pull that API for new product edit events or new other events that we're interested in. So we could repeat that same thing for orders, and then on the inventory, and that's basically where we also pick up back on the, I don't want to actually want the system to actually reach out to another system while it's serving a user request, but it can perfectly have, like, let's say, scheduled tasks that periodically pull those APIs for new events, and then just like keep up on or pick up on where they left off after the last request. You can optimize for certain things there with long polling and whatnot. Actually, like Kafka under the hood, the subscriptions are long polling requests anyway. So it's kind of like, it's not so much different. It's more that you explicitly use those. And that same would work for theoretical system. The fundamental idea is we create HTTP resources for those events, and we have clients to actually poll for them. There's a couple of like implementation design aspects that I've just listed here for reference, and you will find them in the sample code. If you think about stuff like atom feeds, it's basically a media type that's just designed for a collection of things that happen, right? So there's an XML variant. The variant I chose is hell. Using Atom would have like the advantage of being able to debug your production system by just like using your bloody feed reader, if you want to. But yeah, right. So a couple of downsides. Oh no. right? So we actually have to look. The clients are the REST approach puts more emphasis both on the producer and on the consumer. Really, the producer controls the life cycle of the events, how long it actually keeps those around, and the client is basically in control of the inconsistency window, right? If you assume a client deciding to not poll the other API for, let's say, half an hour, then that's just its decision. But in case of heavy load anyway, it might not be flooded or want to be flooded with other messages. Yeah, okay, let's go over this. And the main comparison, or the main difference being that we don't need no other infrastructure, and the event publication actually being dramatically simpler because we just don't need another communication with another infrastructure component, which eases testability and what have you. Publishing systems controls the event lifecycle. I've said that already. They're not really leaving the system to be published. That's interesting as well. And we have that slightly bigger consistency gap, might be. Let me switch ahead to that one graphic I want to show to round things off. It's basically the two approaches basically make up the difference between building a distributed system and a decentralized system, whereas the rest stuff is sort of working towards a decentralized system because you don't rely on that central thing actually controlling stuff. And to make that, or to make that point in a graphical way, I've just basically put on the y-axis, I've put the amount of systems that we actually have to talk to actually do something useful ourselves, and the degree of distributions on the x-axis. And with a monolith, you build a single system, right? And you usually don't talk to anyone else except your own database, or maybe, let's say, a single external system. The microlith, you usually get into danger to having to talk to too many other systems and building a lot of systems yourself. And the thing I usually recommend to actually strive for is to stay on that low on that y-axis, really, to basically not reach out to too many other systems, and rather use asynchronous means to actually update the state and basically create eventually consistent state by using either messaging or that RESTful event approach that I've just shown. If that's it, or that's it actually, thank you very much for coming. I'll be around for a couple more minutes in case you have questions. We can discuss stuff. Thanks for the invitation, and have a great trip home, everyone. Thank you.